Hi guys, let us discuss Dijkstra's algorithm to find the shortest path from single source node to all other vertices in a graph. So in this graph, we are considering the node A as a source node and we want to find the shortest path from the source node A to all other vertices in this graph. So we have to create an initial table with three columns: visited, distance, and previous, and list out all the vertices A, B, C, D, E, F like this. And initially you mark the visited column as 0 for all the vertices and distance as infinity for all the vertices, and the previous column you keep it as hyphen. So the next step 1, so you mark the source node as visited, that is you are making it as 1 in the visited column for node A, that means we have visited node A, and distance is 0. So with this I should identify the nodes I can reach from A with a single edge, that is main important. So with a single edge means we can reach B and C. So what you have to do in the next step, so you mark it as B as visited, and what is the distance from A to B? 4, and from which node you are coming to B? A, that is why previous node as A. And for C, mark it as visited, and what is the distance? 5, and the node which from you are coming is A. So that is a entry you are making it now. So for example, in case of D, we have to see that is there any path with a single edge from A to D. It is not there, so you keep it as it is infinity. And like that for E also, there is no path with a single edge from A to E, again you keep it as infinity. For F also the same case, there is no single edge from A to F, so you keep it as infinity. So this is the first entry, you are making it in the table. So next, what you have to do in the previous table, so we have to consider the visited nodes only. So what are the visited nodes? A is visited, B is visited, and C is visited. So A is the source vertex. So other than this, B and C, you take the node with the lesser distance. Which is the lesser distance? The node B is with the lesser distance 4. So in the next table, what I should see, is there any path with single edge from B to other nodes? So for example here, the entry for B is same as it is. For C, what I should see, is there any single edge from B to C? Yes, it is available, but if we see the distance A to B 4 already, then B to C 11. Why I am considering A to B? Because always we are starting from A source node. So we are coming through B. So 4 plus 11, 15, but already entry was 5. So you need not update. But for D, there is a direct connection between B and D. The weight is 9. Okay. As you come from B, so already A to B is 4. So 4 plus 9, 13. So this 13 is updated here because in the previous table it was infinity. That is, no path was available. So but now I am able to identify some path. So that is why I am entering it as 13. So D will be marked as visited. And what is the previous node? B, because you are coming through B. For E also, in the previous table it was infinity, but now there is a direct edge from B to E with the weight of 7, and already this 4 is there. 7 plus 4, 11. So distance is 11, previous node is B, and mark it as visited. For example F, there is no single edge from B to F, so we are keeping it as 0 and distance as infinity and previous node as hyphen. So now tell me what I should do. Now we should consider the visited nodes. So already visited node la you are considered BA. source vertex, and B is also considered. Now the remaining is C, D, E. So out of this C, D, E, remember that we should consider the node with the lesser distance. So 5, 13, 11, 5 is the least. So in the next table, I will see is there any single edge path from C to other nodes. So the next step, now we have to see that, for example, if you take B, there is a edge from C to B with the weight of 11. So from A to C, 5, 5 plus 11, 16, but already the entry was 4, so you need not update. And C, we are not going to change it as it is. But for example, D, is there any direct edge from C to D? No. So we need not change the entry. For E, listen here, C to E, there is an entry with 3, isn't it? And A to C is 5. 5 plus 3, 8. So in the previous entry, the entry was actually 11. So 8 is lesser than 11. So I will change it. This distance is 8 and previous node is C. Okay, so in the last table, we have marked it as the same entry was 11 with the previous node was B. But now, as I find the shortest path through C to E with 8, so I am updating the table. The distance is 8 and previous node is C and mark it as visited. So now what I should do is refer the visited nodes list. A is the source vertex, B is already considered, C is considered. Now what is the remaining? D and E. When you consider D and E, what is the node with the lesser distance? E, 8. So the next table, I will see that whether I can reach other vertices through E. For example, you take B. So for B, there is a direct edge from E to B. But for reaching E itself, I have to cross the distance 5 plus 3, 8, 8 plus 7, 15. So it is very high value. So you need not update. And for example, C, case of C, to reach E itself, the previous node was C. That means the new distance will not be lesser than that, so we need not update. For D, we have to see is there any path from E. So E to D is 13 is available, but to reach E itself, I have to cross 8. So 8 plus this 13, the distance will become 21, but 13 is lesser than 21, so we need not update. So what about F? So E to F, there is a path single edge with the weight 6. The previous distance to reach E was 8. So 8 plus 6, 14. So the previous node was E and F will be marked as 1. So with this, the process is over. So the A to B, the distance is 4, and A to C, the distance is 5, and A to D through B, the distance is 13, and A to E through C, the distance is 8, and A to F through CEF. Okay, because we are coming to E. When you come to E, you are coming through C. So ACEF, the weight is 14.